Perform the indicated operation. Write the answer using only positive exponents. Assume that variables represent non-zero numbers. Here we have x to the negative 3 raised to the negative 2 power times x to the negative 1 times y, quantity to the second power, all divided by the quantity x times y to the negative 2 raised to the second power. Let's start simplifying by taking care of our outer exponents first. When we raise a power to a power, we multiply those exponents. So in the numerator, x to the negative 3 raised to the negative 2 is x to the negative 3 times negative 2, or positive sixth power. With our second factor, we're going to raise each of these to the second power. X to the negative 1 raised to the second is x to the negative 1 times 2, or negative 2 power. And we also have y to the second power. Now for the denominator, raising each of these factor pieces to the second power gives x squared times y to the negative 2 times 2 is the negative fourth power. Continuing to simplify in the numerator using our product rule, when we multiply like bases, these x's will add those exponents. So in the numerator we've got x to the 6 plus a negative 2 is the fourth power times y squared. In the denominator, let's just leave that as x squared times y to the negative fourth. Now I'd like to use the quotient rule. As we divide these like bases, we'll subtract the exponents. So we've got an x to the 4 minus 2, that's numerator exponent minus denominator exponent, times y to the 2 minus a negative 4. Watch your signs there. As an end result then, we've got x squared times y to the 2 minus a negative 4 becomes a 2 plus 4. So let's call that a y to the sixth power. Therefore, the simplified form for our expression is x to the second, y to the sixth.